Okay, so welcome back. Now today we're going to talk about transformations and how do we graph transformations of exponential functions. Now what's a transformation? A transformation is when you take a basic function and you transform it by either adding or subtracting a constant, multiplying or dividing by a constant, taking some other aspect of it in the y direction or in the x direction, and you're just basically transforming it in some way. Okay, so for example, we're going to talk about today is about vertical shifts. Okay, should have wrote that down. So this is for vertical shifts. That's what we're going to do today. Okay, so that means we're shifting the graph up and down. So here we have the basic function 2 to the x. Okay, and what we're going to do is here's the graph of it, and what we're going to do is a vertical shift is where it's going to move up and down. Now how do we do that? Well, notice that in a vertical shift, what are we doing? The whole graph looks the same except we're moving it up and down. So what are we affecting? We're affecting the y value, okay? So a vertical shift translates to adding or subtracting some constant outside the function. Well, what do I mean by that? That means outside this exponential function, outside this, we're going to add or subtract some constant. So when we add or subtract some constant, that is going to either move up if it's an addition, or move down when it's a subtraction. Okay, and so that is a vertical shift. So how do we graph that sort of transformation? Well, let's take an example. Let's look at, it's called g of x. So in this case here, we're going to do 2 to the x plus 3. So what is that going to do? Well, that's going to take f of x, right? F of x, right? So in other words, you could look at this as g of x is equal to f of x plus 3. So what are we going to do? We're basically going to move up every single point on the graph of f of x, and we're going to move it up 3 points, or 3 units. Now also the asymptote, the horizontal asymptote will also be shifted. So now what would that look like? Well, if we take the 3 common points that all exponential functions go through, which I pointed, that I plotted here, I'm going to move those up. So that means this point is going to move 3 points up. 1, 2, 3. Okay. This point is going to move 3 points up, so that's going to move up to here. And then this here, negative 1.5, is going to move up 3. So that's going to go from half to 1.5 to 2.5 to 3.5. So that's going to go to about right there. Now also the asymptote is moving up 3. So that means the asymptote is going to go from y equals 0 to y equals 3. So we're going to have a horizontal asymptote right there. And so now if I graph this, g of x is going to look like this. Now, what happened to the domain, the range, and the characteristics? Well, we know that the f of x has a domain of all real numbers, a range of from 0 to positive infinity. There's a horizontal asymptote at y equals 0. For g of x, though, well, the domain is the same, all real numbers, but now the range is now 3 to positive infinity, not including 3, of course. And the horizontal asymptote is now y equals 3. Now, what if I take another function, h of x? And I'm going to make this one into 2 to the x minus 3. Well, now, instead of going up 3 units, I'm going to go down 3 units. So that means this one is going to go down 3 to here. This one's going to go down to negative 1/2, negative 1.5. Oh, hold on. Yeah, negative 1/2 to negative 2.5. So that's going to go right about here. And then this one's going to go down 3, so 1, 2, 3 to here. And then, of course, the asymptote also goes down 3, so it's going to go to y equals negative 3. Close enough. And then, of course, the graph looks like that. Now, in this case, h of x has a domain of all real numbers. The range is now from negative 3 to positive infinity. And the horizontal asymptote is at y equals negative 3. Okay, now, is there anything else I'd like to say about that? That's it. Okay, so next time we will talk about horizontal shifts. Have a great day.